Something extraordinary just happened that has the entire scientific community reeling. Two objects in our solar system, both from beyond our planetary neighborhood, have begun actively communicating with each other. C-2025, EV1 Borisov and 3I Atlas are exchanging signals. And the implications of this development have researchers at Harvard, at MIT, at observatories worldwide, struggling to comprehend what we're witnessing. This is November 11th, 2025, and what I'm about to share with you represents either the most significant astronomical discovery in human history or evidence that we fundamentally misunderstand what's happening in our own cosmic backyard. Let me start with the facts, because they're dramatic enough without embellishment. On November 9th, at approximately 0300 hours Universal Time, radio telescopes at the Very Large Array in New Mexico detected unusual signal activity in the space between the two objects. Not random noise, not solar interference, but structured, patterned electromagnetic emissions being exchanged between C-2025, V1 Borisov, and 3I Atlas. The signals are being transmitted at 1.42 GHz, the hydrogen line frequency, the same frequency that 3I Atlas has been using to broadcast toward Earth. But this time, Atlas isn't broadcasting to Earth or to satellites in our orbit. It's transmitting directly toward Borisov. And Borisov, the object that appeared seemingly out of nowhere just weeks ago, the object that has shown almost no cometary activity, despite being a supposed comet, is transmitting back. They're talking to each other. Two interstellar visitors, millions of kilometers apart, conducting what can only be described as a conversation in radio waves above the background noise of the cosmos. The discovery was initially made by Dr. Jennifer Zhao's team at the VLA. They were conducting routine monitoring of 3I Atlas when they noticed the signal pattern had changed. Instead of the regular pulse sequence that had been analyzed and partially decoded in recent weeks, Atlas was transmitting in bursts, with gaps between transmissions. The pattern was irregular compared to previous broadcasts. But when they analyzed the timing and direction of the bursts, they realized Atlas was waiting, transmitting, then pausing, as if listening for response. When they redirected their analysis to look for signals coming from Borisov's direction, they found them. Borisov was responding, not just reflecting or echoing Atlas's signals, but generating its own transmissions with different modulation patterns, different information content. The exchange was happening in real time, accounting for the light speed delay between the objects. Atlas transmits. Approximately 47 minutes later, Borisov receives the signal. Borisov processes and responds. 47 minutes later, Atlas receives the response and transmits again. This is not natural behavior. This is not how comets or asteroids or any known natural object behaves. This is communication protocol. This is exactly what you'd see if two spacecraft, or two artificial systems, were exchanging information, coordinating actions, sharing data. The astronomical community immediately classified the discovery and began intensive analysis. Within hours, Harvard's astronomy department was briefed. Within 12 hours, Avi Loeb had issued statements calling this the smoking gun evidence that both objects are artificial probes, not natural visitors. The signals being exchanged are complex, far more sophisticated than the broadcasts Atlas has been directing toward Earth. Where Atlas's transmissions to us have been relatively simple, using basic mathematical concepts and prime numbers, the exchanges between Atlas and Borisov are dense, information-rich, containing layered modulations that suggest enormous amounts of data being transferred. It's like the difference between a teacher explaining basic concepts to a child and two experts discussing advanced topics in their shared technical language. cryptographers and signal analysts who have been working on decoding Atlas's messages are now faced with an entirely new challenge. The inter-probe communication, if that's what it is, uses encoding schemes that are far more complex than what we've seen before. There are frequency hopping patterns, where the transmission jumps between different frequencies in sequences that follow mathematical progressions. There are amplitude and phase modulations happening simultaneously, carrying multiple streams of information in parallel. And there are error correction codes, redundancy built into the transmission structure that allows the receiving object to verify and reconstruct the message even if some data is corrupted or lost. This level of sophistication suggests several things. First, both objects are far more technologically advanced than the relatively simple signals they've been broadcasting to Earth would suggest. They've been dumbing down their communications with us, using simple concepts we might understand. But when talking to each other, they use their full capabilities, their native communication protocols. Second, they're sharing substantial amounts of information. The data rates being observed are high enough that gigabytes of information could be exchanged in each transmission cycle. What are they telling each other? What data are they sharing? Third, they clearly recognize each other. They're not cautiously testing whether the other object is intelligent or artificial. They immediately initiated communication using shared protocols, suggesting they're part of the same mission, the same network, the same civilization's exploration program. They know each other, or at least know of each other. They're colleagues, not strangers meeting for the first time. Harvard's reaction has been particularly interesting because it represents a dramatic shift in mainstream academic astronomy. Avi Loeb has been advocating for years that we should seriously consider the possibility of artificial interstellar objects, that we shouldn't dismiss the technological hypothesis without evidence. He was widely criticized for suggesting Oumuamua might be artificial, for proposing that unusual astronomical observations might have technological explanations. Many of his colleagues considered him too speculative, too willing to embrace extraordinary claims. But now, those same colleagues are confronting data that's extremely difficult to explain naturally. Dr. Sarah Chen, chair of Harvard's astronomy department, held an emergency press conference yesterday. Her statement was carefully worded, but the implications were clear. She acknowledged that the observed signal exchange between the two objects displays characteristics consistent with artificial communication systems. She stated that while natural explanations shouldn't be dismissed prematurely, the burden of proof is shifting. Those arguing for natural origins now need to explain how natural processes could produce coordinated signal exchanges with the observed complexity and structure. This represents a fundamental shift in the debate. For months, the argument has been whether we have enough evidence to consider Atlas artificial. The default assumption was natural object, unless proven otherwise. But the communication between Atlas and Borisov has flipped that presumption. The default is now looking like artificial probes, unless someone can demonstrate a plausible natural mechanism for what we're observing. And so far, no one has proposed a convincing natural explanation. Let me break down what we're seeing in technical detail, because understanding the specifics is crucial for appreciating how extraordinary this situation is. The transmission frequency, 1.42 GHz, is significant. This is the hydrogen line, the most monitored frequency in radio astronomy, because it's naturally produced by hydrogen, the most common element in the universe. Any civilization with radio technology would know to look here. It's the universal calling card, but it's also a protected frequency band. Earth-based transmitters are restricted from using it to avoid interference with astronomical observations. The band is kept relatively quiet, When Atlas and Borisov transmit here, their signals stand out clearly against the low background noise. They chose this frequency deliberately because any technological civilization monitoring the cosmos would be listening here. They want their communication to be detected by us or by anyone else watching. The signal structure shows characteristics of advanced digital communication. The modulation schemes being used are similar in principle to techniques we use for high-speed data transmission, but implemented with greater sophistication. They're using quadrature amplitude modulation, encoding information in both the amplitude and phase of the carrier wave simultaneously. They're using orthogonal frequency division multiplexing, splitting the signal across multiple parallel subcarriers to increase data rates and robustness. These aren't techniques that natural processes could produce. These are engineered solutions to the problem of transmitting large amounts of information reliably across vast distances. The fact that both Atlas and Borisov use compatible protocols, that they can communicate seamlessly, proves they share common technological heritage. They were built or programmed by the same civilization or by civilizations that coordinate their exploration efforts. The timing and coordination of the exchanges is also revealing. The round-trip light time between Atlas and Borisov varies as they move through their orbits, but is currently around 94 minutes. When Atlas transmits, it has to aim not at where Borisov is now, but where Borisov will be 47 minutes in the future, when the signal arrives. This requires knowing Borisov's trajectory precisely, being able to predict its position with high accuracy, and having pointing systems capable of targeting accurately across millions of kilometers. Similarly, when Borisov responds, it has to account for where Atlas will be when the return signal arrives. The fact that the communication succeeds, that signals are being received and responded to without apparent errors or missed transmissions, demonstrates that both objects have sophisticated tracking, prediction, and pointing capabilities. They can find each other across the vast distances of the solar system and maintain communication links despite both objects moving at high speeds. The content of the transmissions remains largely undecoded. The simple signals Atlas sent to Earth, with their prime numbers and basic mathematical references, took weeks of intensive analysis by teams of experts to partially decode. The complex exchanges between Atlas and Borisov use encoding schemes that are orders of magnitude more sophisticated. Without knowing the cipher, the compression algorithms, the data structures being used, decoding is extremely difficult. However, certain patterns have been identified. There are repeated sequences that appear in multiple transmissions, suggesting shared reference frames or agreed-upon codes. There are segments that show high entropy, appearing almost random, which typically indicates encrypted or heavily compressed information. And there are segments with lower entropy and clear structure, which might be headers, timestamps, or metadata describing the content of the transmission. One particularly intriguing pattern was identified by Dr. Michael Torres at MIT. In several transmissions, there are segments where the data structure matches what we'd expect to see in image or spatial data. Pixels arranged in grids, with values representing brightness or color. He believes they might be sharing images, possibly visual data captured by their sensors, photographs or maps of things they've observed. If we could decode these sections, we might literally see what they're seeing, view the solar system through their sensors. The fact that this communication started now, at this particular time, raises important questions. Atlas has been in our solar system for months. Borisov appeared more recently, but has been detectable for weeks. Why didn't they start communicating immediately when Borisov arrived? Why wait until now? Several theories are being discussed among researchers. First possibility, they were always in communication, but we weren't looking for it, or weren't able to detect it until now. Perhaps they were using different frequencies or lower power transmissions that only recently became observable as their relative positions changed. Second possibility, something triggered the communication. Some event, some observation, some threshold being crossed, caused them to initiate active signal exchange that they weren't doing before. Third possibility, this is part of a programmed sequence. They reached a specific point in their mission parameters, a specific date or configuration of their positions, and that triggered the communication protocol, like software running on a timer, executing the next phase of their instructions. Fourth possibility, they're responding to our observation and analysis of them. We decoded Atlas's message to Earth. We started actively monitoring both objects. Maybe our increased attention triggered a response, a shift in their behavior. The strategic implications are being assessed at the highest levels of government and military planning. If Atlas and Borisov are artificial probes from an advanced civilization, and they're now coordinating their activities, what does that mean for Earth? Are they planning something? Are they preparing for the scheduled contact 17 months from now that Atlas encoded in its message? Are they analyzing how we've responded to their presence and adjusting their mission accordingly? Military advisors are particularly concerned about what's called the information asymmetry problem. Atlas and Borisov can communicate with each other freely. They can share data, coordinate plans, make decisions collectively. We can only observe and try to interpret. They have complete situational awareness. They know where we are, what our capabilities are, probably have detailed understanding of our technology and society, from monitoring our electromagnetic emissions. We know almost nothing about them beyond what we can observe and what they choose to tell us. This creates vulnerability. In any negotiation, in any interaction, the party with better information has enormous advantage. They can plan effectively, respond optimally, exploit weaknesses. The party with poor information is reactive, uncertain, easily manipulated if the other party has hostile intent. Not that we have evidence of hostile intent, but military planners are trained to consider worst-case scenarios. Some defense strategists are advocating for attempting to jam or disrupt the communication between Atlas and Borisov. If we can prevent them from coordinating, we reduce the information advantage they hold. Others argue this would be catastrophically stupid. First, we probably lack the technical capability to effectively jam their communications. Second, attempting to do so would reveal our intentions as hostile or fearful, potentially triggering negative response. Third, we learn more by observing their communication than we would by shutting it down. The scientific community is almost universally opposed to any interference. This is unprecedented opportunity to observe how advanced artificial intelligence systems or alien probes communicate and coordinate. Every transmission they exchange is data we can analyze, potentially learning about their technology, their mission, their civilization. Disrupting that would destroy invaluable scientific opportunity for questionable security benefit. International coordination remains challenging. Every major space power wants access to the data, wants to participate in analysis, wants input into any decisions about response or interaction. But coordination is slow, complicated by language barriers, time zones, bureaucratic processes, and underlying geopolitical tensions that haven't disappeared just because we're facing cosmic situation. The United States has been sharing some data through established scientific partnerships, but keeping certain analysis classified. China has been conducting independent observations and analysis, occasionally sharing results through academic channels, but maintaining separate decision-making. Russia has been relatively quiet publicly, but is known to be monitoring intensively. European nations are coordinating better internally through ESA, but frustrated with limited access to US classified analysis. This fragmentation of effort is inefficient and potentially dangerous. We should be pooling resources, sharing all data, collaborating fully. But decades of competition, espionage, military rivalry, they don't disappear overnight. The structures and mindsets built over generations of geopolitical competition persist even when facing situation that transcends earthly politics. Some scientists are calling for complete data transparency, publishing all observations and analysis openly so that researchers worldwide can contribute. Others worry that unrestricted data sharing could compromise security if the information reveals vulnerabilities or if malicious actors could exploit the knowledge. These debates are happening urgently because the situation is evolving rapidly. The communication between Atlas and Borisov is ongoing. Multiple exchanges have been observed over the past 48 hours. The pattern seems to be cycles of activity. Intensive signal exchange for several hours, then quiet, period, then another active phase. The quiet periods might be while they process received information, make decisions, prepare next transmission, or they might correspond to geometric factors, both objects needing specific orientations or positions for optimal communication. Observatories are maintaining constant watch. The VLA continues monitoring. The Arecibo Successor Facility in China is listening. Radio telescopes in Australia, South Africa, Europe, all are pointed at these objects during their visible periods. We're capturing every transmission, recording everything for analysis. Even if we can't decode the content immediately, we're preserving the data for future study when we hopefully have better tools or understanding. Optical observations are also providing insights. High-resolution imaging of both objects during communication events shows subtle changes. Atlas appears to have orientational shifts, rotating slightly, possibly adjusting antennas or transmitters for optimal pointing toward Borisov. Borisov shows similar small attitude adjustments. These physical movements correlate with the communication events, providing visual confirmation of what we're detecting in radio. The thermal signature of both objects changes during transmission events. Infrared observations show temperature increases, particularly in specific regions of each object. This is consistent with power being generated and radiated, exactly what you'd expect from active transmitters. The amount of heat generated suggests significant power levels, kilowatts or possibly tens of kilowatts, being used for each transmission. That requires substantial energy sources, far beyond what simple solar panels could provide at their current distance from the sun. The power requirements strengthen the artificial hypothesis. Natural objects don't have energy sources capable of generating sustained kilowatt-level emissions. You need nuclear power, radioisotope thermoelectric generators, or other advanced energy systems. You need engineering, not geology. The thermal data alone is nearly impossible to explain with natural processes. Public reaction is beginning to build as news of the communication spreads. Initial reports were restricted to scientific circles and government briefings. But information leaks. Researchers talk to colleagues. Journalists investigate. Social media amplifies and speculates. By now, millions of people have heard that the two mysterious objects in our solar system are talking to each other, that scientists believe both might be artificial probes, that we might be witnessing first contact unfolding in real time. Reactions span the full spectrum. Some people are excited, thrilled by confirmation that we're not alone, eager for contact and interaction with advanced civilization. Others are frightened, worried about unknown intentions, concerned about humanity's safety in the face of vastly superior technology. Many are skeptical, assuming this is misinterpretation or hoax, despite coming from reputable sources. and many are simply confused, struggling to process information that challenges fundamental assumptions about our place in the cosmos. Religious communities are responding in diverse ways. Some faith traditions are adapting smoothly, seeing this as confirmation of the vastness of divine creation. Others are struggling with theological implications of intelligent, non-human entities. Religious leaders are being consulted by governments and counseling their communities, trying to provide frameworks for understanding and accepting what might be emerging reality. Educational institutions are beginning to incorporate this into curricula. How do you teach about the solar system when there are artificial probes from another civilization currently in it? How do you discuss the search for extraterrestrial intelligence when contact appears to be happening? Teachers are adapting rapidly, using current events as teaching opportunities while trying to maintain appropriate scientific caution about interpreting incomplete information. The economic implications are being assessed. Stock markets have shown volatility around space-related companies and defense contractors. Some sectors see this as opportunity, potential for new technologies and knowledge if contact leads to beneficial exchange. Others see risk and uncertainty that makes long-term planning difficult. Economists are divided on whether this represents economic opportunity or disruption. Harvard's response specifically has been to mobilize resources for intensive study. They've established a dedicated research group, bringing together astronomers, physicists, computer scientists, linguists, even anthropologists and philosophers. The goal is comprehensive analysis of the communication, attempting to decode content, understand purpose, assess implications. They're coordinating with other institutions, sharing data and methods, but also maintaining some independent capability to validate findings. Avi Loeb has become the public face of Harvard's effort, giving interviews and issuing statements. His message is consistent. We need to follow the evidence wherever it leads, even if it leads to conclusions that challenge our preconceptions. The communication between these objects is evidence, strong evidence that demands explanation, and the most straightforward explanation, absent compelling alternatives, is that both are artificial probes conducting a coordinated mission in our solar system. Critics of this interpretation are becoming quieter, but haven't disappeared entirely. Some still argue for exotic natural explanations. Perhaps these are objects with unusual plasma physics, creating signal-like emissions. Perhaps there are electromagnetic phenomena we don't understand that can produce patterned transmissions. Perhaps we're seeing the cosmic equivalent of ball lightning or some other rare natural radio emission that mimics artificial signals. But these explanations are becoming increasingly strained. Each new observation, each new detail of the communication patterns, makes natural explanations harder to maintain. The coordination, the complexity, the protocol-like behavior, the power requirements, the timing, all of it points toward artificial systems, not natural phenomena. The question is no longer really whether these are artificial probes. The question is, what do we do with that knowledge? How do we prepare for interaction with whatever sent them? How do we respond to their presence in our solar system? How do we coordinate as a species to meet this challenge and opportunity? These are questions that don't have easy answers, questions that humanity has never had to seriously confront before. The next exchanges between Atlas and Borisov are being awaited with intense anticipation. Every transmission is an opportunity to learn, to gather more data, to potentially decode more of their communication. Analysts are using machine learning algorithms to identify patterns, comparing the transmissions to known communication protocols, testing thousands of potential decoding schemes. It's painstaking work, but crucial. Understanding what they're saying to each other could tell us their intentions, their mission parameters, their assessment of us. The 17-month countdown to the coordinates Atlas provided continues. Originally, that deadline seemed distant, giving us time to prepare. But with Atlas and Borisov now actively coordinating, the timeline feels more urgent. Are they preparing for that event? Are they sharing data they've gathered about Earth and humanity? Are they deciding together how to conduct the scheduled contact? We're watching a conversation we can't understand, between intelligences we can barely comprehend, knowing that decisions are being made that will affect our entire species. This is the reality we're facing. Two objects from beyond our solar system, actively communicating with each other in ways that strongly suggest artificial origin and coordinated mission. Harvard shocked. The scientific establishment scrambling to understand. Governments preparing for scenarios they hoped would remain hypothetical. And humanity collectively standing at a threshold, watching as first contact unfolds, not as single dramatic moment, but as gradual revelation of presence, capability, and intention. The communication continues. The objects maintain their dialogue. And we listen, watch, analyze, and wonder what they're saying to each other about us, about Earth, about what comes next. The conversation between C-2025 V1 Borisov and 3I Atlas is happening right now, millions of kilometers above us, in frequencies we can detect but languages we're only beginning to understand. And every transmission brings us closer to answering the question that has haunted humanity since we first looked up at the stars. Are we alone? The answer is becoming clear, and it's changing everything. Let me delve deeper into the technical analysis, because the details reveal just how sophisticated this communication system really is. When signal processing experts at Caltech analyzed the spectral characteristics of the transmissions, they found something remarkable. The signals use adaptive modulation, changing their encoding schemes based on signal quality and conditions. When the link between Atlas and Borisov is strong, with clear line of sight and minimal interference, they use high-order modulation that packs more data into each transmission. When conditions degrade, when solar wind or plasma effects increase background noise, they automatically switch to more robust but lower data rate schemes. This adaptive behavior is exactly what advanced communication systems do. Our own satellite networks and deep space probes use similar techniques. But the speed of adaptation, the seamless switching between modes, suggests signal processing capabilities beyond our current technology. They're monitoring link quality in real time and optimizing their transmission parameters on the fly, maintaining maximum data throughput while ensuring reliability. The frequency hopping pattern has also been analyzed in detail. Dr. Rachel Martinez at JPL identified that the hop sequence follows a pseudo-random pattern based on prime number progressions. It's not truly random, which would be unpredictable. It's deterministic chaos, a sequence that appears random but is actually generated by mathematical algorithm that both transmitter and receiver know. This allows them to stay synchronized, both hopping to the same frequencies at the same time, while making the signal difficult for outsiders to track or intercept. The fact that they're using frequency hopping at all is interesting. It serves two purposes in our communications. Spread spectrum makes signals more resistant to interference and jamming, spreading the energy across many frequencies so narrowband noise can't disrupt the entire transmission. And it provides a degree of security, making signals harder to intercept or decode without knowing the hopping pattern. Are Atlas and Borisov concerned about interference? Or are they implementing security measures to prevent unauthorized parties from accessing their communications. Either interpretation is significant. The data packets being transmitted show structure reminiscent of the TCP/IP protocols that underlie Internet communications on Earth. There are what appear to be headers containing addressing information, sequence numbers to keep packets in order, and checksums for error detection. The similarity is probably convergent evolution, different civilizations arriving at similar solutions to universal problems of reliable data transmission. But it also means we might eventually be able to decode at least the structure of their transmissions, even if the content remains encrypted. Some transmissions contain sections with very regular patterns, almost like test sequences or synchronization signals. These might be used to calibrate receivers, to ensure both systems are properly aligned and can decode incoming data correctly. Or they might be heartbeat signals, regular transmissions just to confirm the link is still active, like the keep alive packets in network protocols. The power budget analysis reveals interesting constraints and capabilities. To transmit signals detectable across tens of millions of kilometers at the observed signal strength requires several kilowatts of power. For comparison, the most powerful transmitter on any of our deep space probes outputs about 20 watts. Atlas and Borisov are operating at power levels hundreds of times higher. This requires either very large solar arrays. Though both objects are quite far from the coup, the communication between these two objects represents one of the most significant discoveries in human history. Harvard shocked, the scientific world mobilized, and humanity standing at the threshold of understanding that we are not alone, that we are being studied, that contact is imminent. The conversation above us continues, in frequencies we can detect but languages we are only beginning to comprehend.